Hello ladies and gentlemen, welcome back to C.A.R. Entertainment. I'm your host Dylan Hamilton today, guys, and we are going to be continuing our A21 digital technology revision videos, guys. And we're moving on now to expert systems, something which we talked about, or we actually just said of what it can be used in whenever we talked a little bit about our was it data modeling, I believe it was. If not, you can correct me and go back. But yeah, expert systems, something that can be. Sorry, it was AI actually. It was the very first video we did. It was artificial intelligence. We're going to talk about how that can be used in an expert system and what an expert system is. So let's go. An expert system is just an application that seeks to mimic the knowledge and experience of a human expert. So, for example, like a doctor, this system will seem to mimic that. It'll seem to mimic who a doctor is. It is designed to provide a reasonable answer when given a set of conditions about the problem at hand. They are used in medical specialists, financial services, some engineering departments, and repair technicians. Now, the structure of an expert system, you can be tricked into it. They may call it a knowledge-based system, so just know that. And the structure of an expert system is that the knowledge of the human expert will be available through a computer package. That's essentially what it is. So let's go through all the different components to start with. Right, well, you need to know this thing called the knowledge domain, and this is a field of knowledge. It is the goal of the design team to capture the knowledge of a human expert relative to some specific domain and then code this into a computer in a way that knowledge is available to a less experienced user. Computers are then programmed to accept a large number of items based on rules to make decisions, and this is done through three main components known as a knowledge base, which is made up of facts and rules, the Inference Engine, which is using a decision tree or a more advanced heuristic, and then the user interface, which is a menu-based, or if you have a more advanced natural language interface. So let's go through and talk about those now. Well, let's start off with knowledge and what knowledge actually is within an expert system. You start out with knowledge acquisition, which is whenever the subject expert, such as a doctor, then you have a team of programmers and knowledge engineers will be required to try and code this and to try and get this. So your subject expert will include a team of programmers and knowledge engineers. And this is the initial stage of building an expert system. You then go through knowledge engineering, which is facts and rules which are captured by interviewing human experts or completing detailed questionnaires. You essentially go to a doctor, interview him, get all this information from them, which will be programmed into the system. The result from doing all this is a knowledge base, which is stored as a series of if-then-else rules. This knowledge base will store factual and heuristic knowledge. The difference, well, factual knowledge is factual information which is acquired by knowledge engineers, and information is widely agreed, so there's going to a doctor, which all the doctors agree is known as a fact. But then heuristic knowledge is whenever you capture information about accurate judgment and the ability to estimate and evaluate. So it's things that you have to estimate it's not 100% accurate. The rules are not derived from logic but instead experience. So a person who's maybe been in the field for 15 years, they'll know more. And this is then designed to work with uncertainty and simulate producing decisions based on experience. So let's go through and talk about your task domains and different stuff that actually occurs. Well, the expert is our experienced practitioner of technology. That's easy enough to know. And then this knowledge of this human expert will be programmed into the system, and this is done using these rules. In fact, we talked about knowledge. So it holds all the knowledge. So a task domain is what holds all the knowledge of the system containing facts and rules. So the task domain then is an area of expertise that the expert system is designed to work with, and that's essentially the best way to talk about it. Task domain, an area of expertise that an expert system is designed to work with. And then within it, you have all this knowledge of the system which contains facts and rules, which is in your knowledge base. You then have knowledge engineering, which we talked about, is facts and rules captured by interviewing human experts or completing detailed questionnaires, and the result is your knowledge base stored in a series of if-then-else statements. I include that second time because it's really, really important. So your inference engine, then let's go on to your second component. Well, your inference engine is a software that interrogates the knowledge base. So it takes all these rules and figures and it interrogates it, and it tries to draw an inference conclusion based on these rules stored about the subject domain. It poses questions to the user and then uses these answers provided by the user to determine a suitable response. For example, in the NHS, you can go through and try and find out what's wrong. They'll ask you, has your cough been going on for more than 3 weeks, blah, blah, blah. You go through, you give your answers, and it'll go through this sort of decision tree thing, or a heuristic system, and then to give you your answers. And in every answer you give, they'll have the rules or your rule or your what was the other term? I'll just say the rules that was given by the expert, in the interview. It'll be linked in so we know what the answer will be or where to go from there. Like I said, it's done through a decision tree, which is the simplest form of inference engine, and you don't answer with a yes or no. But if you don't answer the question with a yes or no, then you have to use heuristics instead, and this is whenever you work with uncertainty to provide answers based on experience, and this includes making use of AI, fuzzy logic, and backward chaining algorithms. So let's go on and talk about the user interface, which can bring in fuzzy logic and a wee bit more. So the user interface is how the expert system will present this question to you and how it will provide them. They can be given a choice of answered radio buttons, so for example, just buttons where you click on, right, this is what my answer is, this is what my answer is, and combo boxes, or you can give an open-ended text box where you just type in your answer. But it's better to sort of give the buttons and stuff. It's easier for the expert system to operate. It makes it simpler to construct the inference engine based on decision trees answers constrained to a limited set of possibilities when using an interface like that. If you have a complex user interface, then this will request information, which is then passed from the user interface to the inference engine, which is then requested and processed by the engine, applying rules to the knowledge, which then returns a response. So let's then talk about the expert system shell and its fuzzy logic. Well, the shell is just a piece of software which contains a structure for creating an expert system. The creator can enter in appropriate rules and facts to generate a system. It's just the shell, you know, it's just the base of it, and then you enter in your knowledge base and all into that. Fuzzy logic is an approximate way people think when they approach a problem based on truth, as opposed to Boolean logic. It consists of if-then rules rather than if-then-else. And unlike a standard conditional logic, the truth is the matter of degree. So it deals with vaguer answers, such as an advanced natural language interface, where it parses speech to extract its meaning. And this means then passed to an inference engine. So let's go through different uses for expert systems. And you start off with medicine, which is used for diagnosis and the treatment in a range of medical contexts, which ensures timely and effective decision making takes place, and this happens whenever you have to decide who gets treated first. If a specialist might be in a different part of the world, you might need to use the expert system instead. If you're unsure about a diagnosis and you need to check with someone more experienced. It can also be used in C.A.R. engine full diagnosis, where the C.A.R. manufacturer will create their own expert systems in the C.A.R. So if you go up the link at the ICU in the C.A.R., that's the expert system. So yeah, computers plugged into the C.A.R. determining the nature of the fault, and the system will recommend how you fix the problem. But we then go on to talk about life insurance, which then its expert system will consider many factors such as your age, gender, smoking status, and your health, and it will present questions based on responses through the use of an inference engine, where it will interrogate the knowledge base, producing a cost per premium based on the individual response. The advantages of using an expert system is that it can be used as a training aid to increase the expertise of staff. They don't get tired or overworked. They'll perform the same tasks much faster than a human expert, which will calculate a benefit claim. And successful expert systems are very accurate, and possibly more so than a human. The disadvantage is that a lot of effort and cost go into making a good expert system. They're not as good as a human expert, as they're unlikely to come up with creative solutions. So that's where your heuristic knowledge comes in. It's just not as good as a human. The menu-driven ones will not deal with ambiguous problems, and they don't learn from mistakes like a human. Thanks for watching this video. I've been Dylan Hamilton from C.A.R. Entertainment, and I'll see you next time.